it is to the point where most of the traffic that you get on a big website just does not come from humans.
Mm-hmm.
And honestly, as a writer, like as someone who bears my soul onto the page in order for you to learn from my mistakes so that you do not repeat them, it hurts, like spiritually or something.
And this approach with tools like Anubis isn't like, yes, it works, but it isn't a great approach, because now you're in this situation where even regular users are being punished for visiting your website. Like they have to wait whatever ends up being best case scenario, like a couple of seconds. Worst case scenario, as you posted in one of your, I think maybe did you post or someone else? I've seen someone post where it went up to like multiple minutes to go through. When they were using a phone on, it is like a low powered phone on a page being hit quite often. And it's just like this is not a great solution, but at the same time, we're not in a great scenario.
Yeah, I am working to try to find ways to find like patterns with quote unquote known good clients and just let them through. Oh my gosh, there is a fractal maze of rabbit holes in this problem.
Okay.
Especially with things like TLS and TCP fingerprints. Oh my goodness, those are a rabbit hole.
You know, let's go. Where does that take us?
Okay, so let's go to Narnia. But the TLDR is that TLS, or Transport Layer Security, it's the S in HTTPS, is a protocol that allows you to encrypt a connection end to end. This is why you don't need a VPN. It's already encrypted.
My VPN offers military grade encryption.
Have you seen the latest? Have you seen the latest VPN ads? The new framing that people are using?
Yes.
Quantum level encryption.
I mean, like, yeah, technically you could put a post-quantum cipher in there and then say it's quantum level encryption, but like, we know what you're doing. But the TLDR of TLS is that it's a protocol for encrypting connections. And in order for the client and server to be able to agree on stuff, they have to say which set of extensions to TLS they're using, like what cipher suites are they using, and what key exchange mechanism are they using, and what is the name of what is the server name, so that the server knows which certificate to send back, and all that. And a lot of that information is unique enough to identify an individual client. Like the Go programming language TLS stack will have a different fingerprint than Google Chrome, than Python requests or Python URL lib. Those actually have different fingerprints, and other things. And those allow you to be able to make more detailed inferences, like, hey, wait, this is Chrome on Windows claiming that it's Chrome on Linux. That's kind of sus, bro. And be able to filter things like that. And I want to be able to do that in the future. But the problem is, in order to do that, you have to have your code sitting at the TLS termination layer. And I have attempted to do this, and modern cloud platforms, they make it annoying.
Right.
The best experience I had was when I set up a sacrificial lamb cgit server with the Linux kernel, just as like bait for the AI scrapers. They took the bait, but yeah, there is a saying that someone in site reliability told me when I was starting out in the industry, is that given enough time, all problems will become big data problems. And in order to not show the challenge page for Anubis as often, it is starting to become a big data problem.
Right.
Ideally, it won't be actual big data. Like, ideally, we'll be able to keep the entire data set smaller than RAM. But, God willing.
Does that fingerprinting issue take you into any potential data security issues, or is this just a matter of fingerprinting different types of clients?
If it's a data security issue in your mind, then you're screwed. But, like, like fundamentally, it's just a problem that is very underspecified.
Mhm.
Very little research has been done, and I'm basically implementing stuff out of scientific papers at this point.
I see.
And some stuff like JA3N and JA4 signatures, which I'm
What
still
are those?
researching. They're different ways to fingerprint a TLS connection.
Okay.
There's another standard called JA4T for fingerprinting TCP connections, which in theory would let you detect a VPN,
Mhm.
but I haven't been able to implement it to my satisfaction yet, so I haven't really talked about it anywhere.
So, was this an area that you had knowledge in beforehand, or is this something you've had to educate yourself post the creation of this?
Kind of a mix of both. I've kind of done networking stuff all my career. I worked at a site-to-site VPN company and was able to put a bunch of my networking knowledge to use. When I was growing up, I learned how to proxy Tor over XMPP in order to evade internet filtering. No, I'm dead serious. I lost the code for that. I wish I hadn't. But it was one of those weird cases where the filter would stop any new TCP connections, but if you left a long-running TCP connection, such as an XMPP session, it was totally fine. And Tor at the time had really good support for arbitrary weird proxy methods, and I thought, there is a little terrible Python library that lets me do XMPP, and I have a friend that is very easily amused. Let's see what can happen. And it worked enough. It was not pretty, but it worked.
This sounds like the story of your life. It works enough.
I mean, that's all you need, right? Like, and if it works enough, then you can get to the point where you try to figure out where it fails in practice and then be able to design things around it. Although I ended up not needing it after I learned how to do MAC address cloning, because my terrible laptop had one of the few network cards on the market that let you clone MAC addresses. All you have to do is just find a single device that's immune from internet sleep mode, and then when people aren't using it, you unplug that device's Wi-Fi card, and you're good to go.